Welcome to March 8th LeetCode Challenge, Linked List Cycle. Given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there's some node in the list that can be reached again, continuously following the next pointer. Internally, pause or precision is used to denote the index of the node that tail's next pointer is connected to. Note that pause, the variable pose, is not passed as a parameter. Return true if there's a cycle in the linked list, otherwise return false. So in example number 1 here, we have head being the following linked list as such, right? We draw it out, and we find that the linked list at position 1 connects basically the next pointer of the end to the tail's next pointer. So there is a cycle. Return true if there's a cycle in the linked list, so the output is true. So there's a cycle in the linked list where the tail connects to the linked list at the first node, as denoted by position 1. And also keep in mind the position is not included past the parameter. In example number 2, we have the following. We have a linked list with only 2 nodes, and we have basically the first node is connected, the 0th node actually is connected to the tail node of the first node is connected to the 0th node, as denoted by position 0. So the return true because there is a cycle. Example 3, if we have basically only a single node, then there is no cycle in the linked list because we have only one node. So the constraints are that the number of the nodes ranges between 0 to 10 to the 4, node value between -5 to 10 to the 5 and 10 to the 5. Position is -1 or valid index in the linked list. So position of -1 meaning that there's no linked list or no position that it connects to. We wouldn't know that because it's not past the parameter. So how would we go about solving this question? So this is a classic determine if there's a cycle linked list, and the first thing that comes to my mind is the Floyd's cycle detection algorithm. I'm going to spell it out here. So Floyd's cycle detection algorithm. And I think we used this one before, but here's how it works. So we set 2 pointers. One pointer is going to be a slow pointer, which moves from the next pointer to the next pointer each time. And we have something called the fast pointer, which moves to the next pointer each time. So basically the fast pointer moves twice as fast as the slow pointer. So once we traverse through the slow and the fast pointer until we meet the end, and if they meet again, that means that there's a cycle within the loop, within the linked list. So basically return if slow equals fast, then there is if slow equals fast, then there is a cycle within the list. If not, then the fast pointer will be none. So there's also a bit of math that goes into it as well. Let's see, using the terminology given in the question. So say, let the whole linked list be the length n, right? So we have a distance where the head and the slowed index pointer of the linked list be m. So if we move the distance of slow index pointer and the index where the slow pointer meets the fast pointer, then we know that the first pointer traverses same amount as, so basically we can make the slow pointer equal to the fast pointer if there's a cycle. And here's the algorithm for that. So if head is none or head.next is equal to none, so this just takes the base case out, where if we have a none, then we're going to return false because there's nothing left to return. So we're going to define a slow pointer being equal assigned to head and a fast pointer being head.next, as stated before. So while fast.next and fast.next and slow pointer is not equal to fast pointer. So we want to know basically, well, fast has a next pointer, and well, fast.next exists, and where slow pointer does not equal to the fast pointer, then we want to update the slow pointer to be slow.next. So basically, go to the next pointer after that, go to the next node after that, and we want to update fast to be the next two pointer nodes down the line. So it'll be fast.next. And then obviously we want to return if slow equals fast, then that's going to be true. Therefore, we return that if slow equals fast, that means we could cycle through the loop with a slow pointer, and when the slow pointer equals a fast pointer, which was twice as fast, then we know that there is a cycle because they both meet each other. And that is the idea for the Floyd cycle detection algorithm. And by observation, we can see that the time complexity, or the runtime, is big O of n, where n is length of the linked list. And space complexity is we're returning a boolean, so it is constant space. There you go. Have a great day, guys.